I'm Professor Rad, and today we're going to talk about the different components that make up a fraction. In the last video, we discussed ratios and rates and the different ways that you can express them. And one of the ways that you can express a ratio is by using a quotient format. When we use the quotient format, we're going to refer to that typically as a fraction. And a fraction generally is the type of ratio where you have how many pieces you have, like maybe you ate 6 pieces of a candy bar, out of how many pieces there were total to the candy bar. So in the last video, we had an example of 6 pieces of a candy bar were eaten, and the candy bar was broken into 25 pieces. That type of ratio is going to be called a fraction. So that's our first definition here. So a fraction is a number that represents how many pieces of a certain size there are. They're typically written as a ratio in quotient form. Now, because we'll be referring to the top part of a fraction and the bottom part of a fraction quite a bit, we want to give them names. So the top number is called the numerator, and that tells you how many pieces you have. So I can kind of think about what the numerator means, because numer is sort of like number, right? So I guess you could think of it like numerator. But the numerator is the number of pieces that you've eaten, or it's the number of pieces that you have or that you're looking for. The bottom number, or the denominator, is going to tell you how many pieces make up an entire object. So I always think of denominator, it's the denominator. I don't know why I think of it in that silly voice, but I do. The denominator, you can think of, it goes down. So the D for down, it's the bottom number. Okay, so the number at the bottom. And you can think of it like denomination. So if you think about money, you could have like a $5 bill or a $1 bill. So the denomination is how much the whole bill is worth, $5 or $1. Or with coins, 25 cents versus 5 cents or 10 cents or 1 cent. So the denomination tells you like how much something is worth, the quantity of things for the entire object. That's what your denominator represents. So like how many pieces were in the entire chocolate bar. Okay. Now, the larger the denominator, the smaller the piece size. We'll sometimes call something like this an inverse relationship, when one thing gets big and the other thing gets small. Let's see why this may make sense. Let's say I have a pizza. Actually, I had 2 pizzas, let's say. And we're going to cut them up into a different amount of pieces. So let's say this pizza on the left, I'm going to cut up into 8 pieces. And then let's say this one, I'm going to cut it up into 3 pieces. All about the same size within each pizza, right? So this pizza would have a denominator of 3 because the whole pizza's got 3 pieces in it. Whereas this pizza would have a denominator of 8 because the whole pizza has 8 slices in it. So you can see, as I cut the pizza up into more and more slices, each of those individual slices is smaller than if I cut the pizza up into only 3 pieces. So if I ate 1 slice of this pizza, I would have much more food than I ate 1 slice of this pizza. So the bigger the denominator, the smaller the slice you get, because you're, trying to divide it up amongst more people. So each individual person gets less. So speaking of visualizing things, let's write down the fraction that's represented by the shaded portion of each of these pictures. So the first thing that I like to do when I write out my fraction, I'm going to write my fraction bar. I like to count how many there are total, and that's the bottom number. So I fill out the bottom first because I like to think about the whole picture, right? So we have 1, 2, 3, 4, 5, 6 pieces total. And then for the numerator, we're interested in the portion that's shaded. So we're going to count out how many pieces are shaded. 1, 2, 3, 4. So the fraction of this candy bar that's shaded in would be 4/6. In these pictures I drew up here, this would be 1/8 of a pizza got shaded in, and this one would be 1/3 of a pizza, because 1 out of the 3 slices was shaded, or 1 out of the 8 slices was shaded. Okay, so this picture would be 1/8. This picture would be 1/3. So you can use pizzas or circles, or you can use candy bars. Your candy bars could have just like single rows, or like we have here, we've got a bunch of different squares. What we're looking for is that the whole shape is broken up into pieces that have the same size. So each of these pieces are the same size. Same thing here. Okay, so we're kind of dividing things equally when we break it up. So let's write the fraction of those pieces that are shaded here in part B. So we've got a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So that's the denominator. And then let's count up how many are colored in. So 1, 2, 3, 4, 5, 6, 7. All right, so if you have a picture, now we can write the fraction. Let's talk about going the other way. So this time, in this example, we have been given the fraction. We're going to state the numerator and the denominator, and then we're going to visualize the fraction. So for part A, we have the fraction 3/5, or 3/5. The numerator is the top number, so our numerator here is 3. The denominator is the bottom number, so the denominator is 5. For this one, I'm going to use like a candy bar to represent my fraction. So I've written out my whole candy bar, and I want to break it up into 5 equal-sized pieces. So we'll do our best to make these equal-sized. So we have 1, 2, 3, 4, 5 equal-sized pieces. Nice. Then the numerator tells us how many of those pieces we want to color in. So we want to color in 3 of them. It honestly doesn't matter which 3 pieces you color in. I do like to just shade them in starting from the left, because that'll usually make it easier to compare fractions later on in the future. But honestly, it doesn't matter. All right, let's try the next one. So for part B, we need to identify the numerator and the denominator. The numerator is the top number, so we have 6. And the denominator is the bottom number, so we have 12. All right, so now let's illustrate the fraction 6/12. Let's try a pie for this one just to be different. So you can experiment with different shapes and see which one you like the best. So we have to divide this circle up into 12 equal slices. So I'm going to walk you through my process on this to try and get them as equal as possible. Again, it can be a little bit messy. I do recommend you use pencil, but it just doesn't show up well on the screen if I use pencil. So I know that half of 12 is 6, so I can cut this in half. And I know that, so I need 6 pieces on this side and 6 pieces on this side. And I know that half of 6 is 3, so I can cut each of these in half. And what that means is I now need 3 pieces in each of these sections. So it's about 3, 3, 3, and 3. So total, I'm going to start counting at this one here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Beautiful. We've got 12 pieces shaded. or 12 pieces drawn rather. We haven't done the shading yet. And now we want to do the shading. So we need to shade in 6 of those 12 pieces. So I'm going to do every other piece just for funsies here. So we've got 1, 2, 3, 4, 5, and 6. There you go. So if you like that process that I used or described when I'm cutting up my pie or my pizza here, you can draw your fractions using circles. But generally I find the easiest way is to do like candy bars. And I'll show you another way that we can do for this next one, another way, instead of drawing the whole rectangle to begin with. So speaking of, let's work through part C. This one also has 12 pieces to it. So what I'm going to do is I'm basically going to draw 12 squares that are all connected. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when I'm not sure about, the sizing, or if I notice that as I cut something up, I keep ending up a little bit short, I like to draw my fractions in this way so that I just draw out the total number of pieces. Now I'm going to shade 3 of those in. So I'm going to shade in the first 3. But again, you can shade in any 3 pieces. It doesn't really matter. So that's how we can visualize our fractions. And those are like 3 different techniques that you can use. All right, so here are a few problems for you to try. So in the first 3, you're going to write out the fraction that's represented by the shading. And then in the next 3, you're going to state the numerator and the denominator of each fraction. And I would encourage you to draw out those fractions as well, just to get a sense of what they look like. In the next video, we're going to take our drawings of fractions and use them to allow us to compare whether 2 fractions mean the same, same amount or not. So looking forward to seeing you then. In the meantime, have an excellent day.